So the indirect utility function has different properties. It's defined, as you recall, over a vector of prices and wealth endowment, PW. It has different properties. It's homogeneous of degree 0. It's strictly increasing in W. It's non-increasing in prices. It's continuous in prices and in W. One property that interests me here is that it's also quasi-convex. So what does quasi-convexity means? It means that the lower contour set, i.e. all PW pairs, which are such that the maximum utility available given P and W is less than or equal to some level, V bar, that set must be convex. That's what we're trying to establish. That's the definition of quasi-convexity of a function. So the proof for this is you pick PW such that PW is less than or equal to V bar. So you pick a PW vector in the lower contour set. You pick another one, P prime W prime, such that, again, the maximum utility is less than or equal to the level. And now you have to show that the linear combination, I'm going to call this vector P double prime W double prime, which is what? Which is equal to alpha P plus 1 minus alpha P prime, and alpha W plus 1 minus alpha W prime. Alpha a number between 0 and 1. If I define this linear combination in this way, I have to show that the maximum utility achievable at P double prime W double prime is also less than or equal to the level, right? So it's also in the lower contour set. So any bundle X chosen at P double prime W double prime is such that it must be affordable, right? So I must have P double prime X less than or equal to W double prime. And remember how I've constructed P double prime and W double prime. So I have alpha P X plus 1 minus alpha P prime X less than or equal to alpha W plus 1 minus alpha W prime. Sorry, write this. What this inequality means is that either Px is less than or equal to W, or P prime X is less than or equal to W prime, or both, right? Otherwise the inequality would not hold. So I have Px less than or equal W, P prime X less than or equal to W prime, or both. Now if X is available at the price wealth combination PW, then we know here that U of X is less than or equal to the maximum utility attainable at PW, which we know by definition that we've chosen this to be less than or equal to some level. And if X is available at the price wealth combination P prime W prime, we have the same reasoning here, that it is less than the maximum utility available at P prime W prime, which we know is also less than or equal to some level. So either way, we've shown that u of x, x being the bundle chosen at p double prime, w double prime is less than or equal to that level. So we've shown that the bundle x is in the lower contour set. So the bundle which is formed, which is chosen at a price level and a wealth level, which are formed as a linear combination of p and p prime, is also in the lower contour set. So we've shown that if you pick two such vectors in the lower contour set, then the linear combination is also in the lower contour set. You've shown quasi-convexity. So this concludes the proof.